Hello, people, coming to you from the beautiful outdoors. My wife is inside with her recording, so I didn't want it to get mixed up. Okay, so we are on chapter 6 now. We will be talking about telescopes, okay? So let's start out with 6.1, eyes and cameras. Okay, so here we go. First thing about cameras is they have lenses, or you need to know what refracting is. Refracting is the bending of light as it goes into into some sort of substance, or it could be glass. As light goes into something, it'll get bent. Okay, now the reason why some people say it's because the light is slowing down, but really what's happening is light is being reflected off of a lot of different things, is bouncing around. It's not really slowing down, but that's a good way of describing it, is that light slows down, therefore it gets bent. Here's a little picture of it. I mean, you guys have seen this sort of thing on a glass with when you put something like a straw inside of it or something. You can see the straw gets like cut in half when you're looking at it, and that's the refraction occurring. That's light being bent as it goes into the water, or also when it comes out of the water. Okay, now I even put a little video right here. Now look at, I put the pencil in the background here. I want you to see what I'm doing with it. The pencil looks like it's on the right hand side, yeah, but you can see it over here on the left hand side. That's light being bent, okay, refracted. So that's a good idea. Those are just a couple real quick ideas of what refraction is, okay? So let's go forward. Okay, so we use refraction in our eyes. That's how our eyes work, okay? So the way that works is light goes through the pupil. This is like a pinhole for a camera. And then the lens of your eye refracts light, so it will project on the back of your retina. Okay, on the back of your eye, on the retina portion, and then it will determine what this looks like depending on what is hitting it. Okay, so let's see how this works. So your lens on your eye acts just like a lens on a camera or something, focusing it on the retina in the back part of the eye. And that back there is called the focal plane. Okay, and images, I know some of you guys have probably heard that images are actually reflected on the back of your, or refracted on the back of your eye upside down, and that's true. Okay, because our eyes are what are called convex lenses, and that means that they make the images appear upside down, and your brain sees them and it flips it right side up for you. Okay, so now refraction happens in a lot of things. Okay, so it's not just from like glass or light. You can also have it from air. Okay, so when you look up at stars, they appear to twinkle, right? They appear to blink. And you know that song, Twinkle, Twinkle, Little Star? It doesn't come from nowhere, okay? What it comes from is the light is coming into our Earth's atmosphere, and the atmosphere, the air, is actually bending the light. And what happens is bending it a lot because there's a whole bunch of layers of air, and all those layers have different temperatures, and they make the light it bends the light a little bit differently depending on what the temperature of the air is, and this is called it's refraction of light in the air, and they're turbulent layers of air, and so that's what makes light twinkle. It makes the stars appear to blink. You might think. And then planets don't do this. So if you ever look in the sky and you see something that is not twinkling, that means you're looking at a planet. Okay, and it'd be cool if you go out there and you can use your app that you learned how to use the other day, and you can find a planet and see if you think it looks like it twinkles, and then look at a star and see if you think it looks like it twinkles. Okay, so I got this video on a pinhole camera, how a pinhole camera works. These were the first cameras that they made. Okay, and let's just show you. So I don't know if you've ever thought, like, how in the world did they ever think about how to create the first camera? Like how in the world do you make a camera? What does it do? How does it work? So this will kind of show the first cameras ever built.
Yeah, when are we gonna do the science?
This is science. Hey, I'm Diana. You're watching Physics Girl, and we made a camera obscura in the back of a U-Haul. So last week, I held a meetup in San Diego with donuts and science, which attracted some awesome people, including the star of the show, Lily.
Need everybody to sit
Okay, guys, and I'm
This
just
is
going
the
to go fast
director.
forward to it. Now, what they did was they took this U-Haul, And here, let me see if I can back up a little bit so we can see the U-Haul in it. And they covered this portion with a cardboard box, and then they put just a little piece of paper here and put a hole about the size of maybe like the portion of your thumb is, and look at what happens on the inside of the U-Haul when they do that.
Wanted to make the camera obscura was because they were in the end making
see.
a camera. I'll tell you a little bit. Single hole.
Look, there's
and
how big the
people
hole
out to
is.
Experience this massive camera obscura with us. Are you
Okay,
ready?
let's see what it looks like inside when they do
There we
that.
go.
There you go.
Oh, that's so cool.
Oh, wow, that's really cool.
I know. Dan, can you wave your arms?
Now what you
As
can
your
see
eyes
is you can
adjust
see
to the dark,
images
the
upside
first thing
down.
you notice is that the image is upside down.
That's exactly what your eye is doing.
Cool. It's on the sides, too.
Yeah. Oh man, you can see the scene the whole way around. Awesome. Look at the trees over there in the corner. Oh wow, that's cool.
Oh, whoa.
What is that? That was people shining their phone lights at the back of the U-Haul from the outside, which must have looked hilarious from the outside. Whoa! What was the most surprising thing about it, or?
Because when we saw the
And guys, I want to show you a little bit more into it.
What's over here?
So look at how you can even see colors in there.
Quick side note, my friend
look at the
Dan and I liked
definition
this
you can
experiment
see.
so much that we decided to redo it a third time, but this time put the camera in the back of the U-Haul and hang a sheet from the ceiling a few feet in front of the hole so we could do this. This is our moving U-Haul camera obscura.
Okay, guys, and what they would do to create these cameras is like how they just put a sheet there so it would project onto the sheet. What they would do back then is they would put a piece of like film, and the film, what would happen is whenever light hits it, it burns that thing into the film. So it would burn something like this into the film, but the reason why they were black and white is because they couldn't figure out how to burn color into the film, okay? And that was the first ones that they did, the black and white ones. And ever since then, I mean, we've gotten better at this, obviously. We don't use this idea of a camera anymore. That's called a pinhole camera. What we use now are digital cameras, and instead of having like a sheet or something on the back or like photographic film that burns onto it, what we have is we have these things called CCDs, and they just pick up different colors of light. So there's a bunch of different little spots, and they pick up either red, green, or blue, and then based off of that, they create all the colors that you see. And these are the digital cameras that do this. And notice they still use lenses and they still project the object on the focal plane at the back upside down, yeah? So there's no way to really get around that. This is going to be the best way to do it is with a lens. And I mean, we developed as humans, evolved with these eyes that work amazing, okay? And so also astronomers use this stuff, and they can redefine images. They can combine images. A lot of times what you'll see when you're looking at a astronomical photograph is that's not one picture they took. What it was is probably like 30, 40, maybe even 100 to 1,000 pictures they took, put together and rendered to look more detailed and focused on different things. So that's how these cameras work. And that was 6.1.